Hey everybody, this is Gregory from Dapp University, and today we're going to be talking about building decentralized applications with React.js and Webpack and Web3. So if you haven't seen it already, I have a 2-hour tutorial that shows you how to build your first decentralized application step by step. Now, in that tutorial, we build our back end with a smart contract with the Truffle framework, and we built the front end with just simple HTML and JavaScript file. So the goal of today's tutorial is to show you how to basically take that code and modernize it and use modern web technologies to build your dApps. So that's what we're gonna be doing today. I'm going to be showing you how to use React.js and Webpack along with Web3 and also a Truffle contract. So be sure to check out that video where I show you how to build that application first. You're going to need the backend. And be sure to subscribe to the channel if you'd like to see more videos about how you can build decentralized applications on the Ethereum blockchain. So let's go ahead and get started. You can follow along with this code. I've posted a new link in the Dapp University GitHub. This is going to be Election React. You might have seen the election repository before if you've done the other tutorial. Let's see here. And I've just got a new one where I have rebuilt the front end with these technologies, React and Webpack. So go ahead and grab that code and just clone that repository. And once you have, also I should notice, I'm going to probably keep updating this. So if you want to follow along with the code exactly as it is in the video, I'll put a link to the release. So if you go to version 0.0.1, that's going to be the actual code for this tutorial. And if you don't do that, I may have some changes that might look different than what's on my screen. So if you want to do exactly what's going on today, then grab that release. And that link will be in the description below. So once you've cloned that, let's go ahead and install our dependencies. We can do that by running... you can follow our installation instructions here on GitHub. We'll use npm install to install our dependencies. I've updated all these in the package.json file. All right, the npm install. I've already done this, so I'm going to cancel. And then also, you're going to want to make sure that you have Webpack and Webpack CLI installed globally so that you can run these commands, and you can do that by doing npm install Webpack, or sorry, -g Webpack and Webpack CLI. And again, these instructions are here on GitHub. And lastly, once you have all that installed, you'll want to actually run the application. I have a run script that will launch the server. So you can just do npm run start. You can see that's running Webpack dev server, and it's opening the browser for us. All right, now that that has booted up, Webpack has compiled all of our modules and bundled them. We can see our front-end application has opened here, and this looks a lot like our other app did. It shouldn't look too differently. That's not really the goal. The goal is not to reskin the app. The goal is to rebuild how the front end works. And that's kind of what we did here. So I think it looks a little different. I think I'm using Bootstrap 4 instead of Bootstrap 3. So that's probably why this button looks like a different color and maybe in a different position. But otherwise, it should be pretty close to the same. So let's take a little tour of the technologies we'll be using. So the first piece of technology that we're using is React.js, and this is just a modern JavaScript framework. It's one that I've used a lot on other projects, and I like pretty well. I've used a lot of JavaScript frameworks over the years, and React seems to do a good job kind of once you've got the hang of it for something like this. And I know other Dapp developers are using React as well, so this is a good option for us. You can read more about React on the React.js website here. The other piece of technology is Webpack. Webpack is a module bundler for JavaScript and really all of our assets on the front end. essentially what this is going to do is allow us to manage all of the assets in our source code and build them kind of into one big JavaScript file that we can attach to our index.html file. And it's also going to, if we got other assets like CSS and images and things like that, we can configure Webpack to bundle those as well. And I'll kind of show you what's happening there. The next thing is Web3, and we've talked about Web3 in some of our other tutorials. Web3 is basically just a library that's going to allow our front-end application to talk to the blockchain. And this is going to be, a dependency of our application. And the last kind of major piece of technology is the Truffle contract library. And this is a library that we used in the last tutorial, and it comes bundled with the Truffle framework. But I've also, installed it with NPM for this particular project in order to include it into our front end. Now, the reason I'm including Truffle contract here is to build on top of Web3. Now, I'll show you this more a little bit later when we walk through the code, but a lot of people are using Web3, standalone by itself, but I find that Truffle contract offers a few more features that I really like on top of Web3. And I use both of them together. And I'll show you why in a minute. Basically, Truffle contract is going to allow us to, manage our contracts in a variety of environments very easily, and kind of just going to plug into our project a lot better. It's going to allow us to read some JSON abstractions more easily and things like that. I'll show you that when we walk through the code. So let's go ahead and open up the code and see what's going on here. All right, the first thing that I want to look at is the node modules directory. Well, not the node modules, sorry, the package.json file. And this is going to specify all of the dependencies for our project. Now, there's a lot of things that we need here in order to make this work. I should also mention, so this particular project, I'm writing in ES6, so this is also a modern version of JavaScript. And I like writing things in ES6. For a while, I've felt like JavaScript is a language that leaves something to be desired, and ES6 seems to be an improvement upon some of those desires from JavaScript. I like it, and there are a few things we need to bring into our project in order to work with ES6, because many browsers won't support ES6 natively out of the box. At least we can't count on them to. So we need something to basically compile or transpile ES6 into an older version of JavaScript that they can understand, and that's exactly what Babel does. So we have to import several Babel dependencies into Webpack. Actually, also, I'll just throw this website up here. Yeah, if you're curious about Babel, you can read about that here. Yeah, so Babel is just, this JavaScript compiler. You can kind of play around with the input from ES6 to, an older version of JavaScript. So anyways, yeah. So Babel, we need all our Babel dependencies in order to support ES6. I've added Bootstrap here, which is our templating framework. It's, gives us a lot of nice looking UI elements and JavaScript interactions and CSS all for free. This is a CSS loader for Webpack, which is going to allow us to, load CSS files into our module bundle. Let's see other important stuff. JSON loaders also for Webpack. It allows us to load JSON files. We'll use this to load our contract abstractions when we read them with Truffle contract. React from React.js. React DOM, which, React you can use outside of the context of a web application. You might have heard of like React Native or something like that. So we need React DOM to actually, interact with the DOM, or the document object model, our web page itself. React Strap, this is a React library that I've kind of been experimenting with that will just kind of give you some React components for free in React. A style loader for Webpack, Truffle contract, Web3, Webpack, Webpack CLI, and then Webpack dev server. All these are Webpack related. So that's an overview of all the dependencies that you need to get started. Also, just noticed I've added a few scripts here. So now Webpack dev server is, it's a library that's going to compile all of our Webpack assets kind of on the fly and give us a little HTTP server that we can use and run locally when we're developing. Again, you can see that's going to run on port 8080 here. And yeah, so the other thing is, Webpack also have a build script. So like I said, when we're developing locally, Webpack's just going to compile our assets on the fly. And when we, want to deploy our front-end application, we want a build, and that's exactly what Webpack's going to do. It's going to create a build for us in our dist directory here, and I'll show you that here in just a second. So anyways, I've added these scripts to the package.json so that you can do these things quickly with the npm command line tool. So let's go ahead and take a look at the Webpack config. I just kind of have a general config file here. We could, break this out into a development configuration and production configuration, things like that. But I've just done a simple configuration for the sake of this tutorial. So how Webpack works is it takes an entry path and an output path and basically says, hey, look for all your assets, here. And, at that entry point, the entry point will specify all the dependencies that it needs. And whenever you, build your project with Webpack, it will, take all the dependencies that are specified underneath this entry point and bundle them to kind of a single build for the output. So we're just telling Webpack to look here in our source directory in app.js. And we'll look at this here more in a minute. But basically, app.js is going to be our entry point for all of our dependencies in our project. And this is the dev server configuration. It's basically saying, look for everything in the source directory and compile this on the fly. The next thing are the module loaders. So basically, this tells us how to load CSS files, how to load the JSX templates for React, and also I've added a JSON loader and specified the contracts directory that's exposed by Truffle. And I'll show you why we do that here in a minute, but just notice that I've included this directory. And now I think with this version of Webpack, the JSON loader has been included by default, but I needed to specify this particular directory, I'm pretty sure, in order to expose this to our application. Now, I'll just show you. Our root directory is build, contracts, and we'll open election, for example. Now, this is the contract abstraction that gets built by Truffle every time we migrate our contract. And this is basically, we want our Truffle framework to talk to our front-end application in this way. We want to be able to fetch this from our project in our front-end application while we're developing. And that's exactly why I have specified this path here. So, all right, that's our Webpack config. Let's take a look at some of the actual source code for the app. Now first, I'll show you that the index.html file looks, very clean and simple compared to the other project. That's because, React, or for a couple reasons, React manages all of the kind of view and template logic in the same file. React uses components, and those components use JSX templates, so they essentially mix, view logic and things like that with the template code. And Webpack essentially attaches this single build.js file. This is the file that Webpack creates. So we don't have to list out every single, require statement here, not require statement, but, every single JavaScript tag. We don't have to, say, here's a script with a source of, Bootstrap and React and all that kind of stuff in our app. It just puts everything into one file here. The next thing is we have just a simple div tag here with an ID of root, and this is the container that React is going to attach our app to, and I'll show you that here in a second. So with that being said, let's go to our main app component for React. So essentially we have, let's see, 4 components. We have a main app component that kind of governs, our whole app. It's the top level. It's going to manage our state in React and kind of our app configuration, setting up Web3, instantiating our contracts and things like that. And it's going to render all of these subcomponents. We have a content component, a form component, and a table component. So I'll just kind of tab over to the app here. So basically our app component is going to manage, this whole thing. It's going to manage kind of how this whole thing works. And then it's going to render a component that governs essentially all this content. And all of that content is going to get broken down into a table that's going to, list out the candidates and a form that allows you to vote for, the candidate. And that's going to have all of its logic. So yeah, the idea of breaking those out into components is that, this form is going to have kind of its own logic that can be kind of encapsulated within that component. And same thing for the table. And I think the account is just rendered in the content component. So go back here and take a look. So we'll start with the app component. We have, first we have, our import statements here. These are just the libraries supplied by Node, React, React DOM, Web3, and also Truffle contract. Now the election JSON is imported from our build contracts directory supplied by Truffle. And I had to configure Webpack in order to be able to load this in here. It's kind of what I talked about a minute ago, and I'll show you the meaning of this more in a second. We have the content component that I just talked about. That's going to render all the content below, and then just the Bootstrap CSS. All right, so let's kind of walk through the constructor first. I'm using the component state in React to manage, our app state. It's kind of just a simple implementation for this particular, voting tutorial. And we can talk about state more here in a second. But I'll walk you through the rest of the constructor. We are setting up Web3. This is how we configure Web3. This is, how we're going to allow our decentralized application to talk to the blockchain. And I talk about Web3 more in my other tutorials, specifically the 2-hour election decentralized application tutorial and a few others. So you can, see more about Web3 in those videos. But essentially, I'm just giving a provider that's injected by something like MetaMask into our application, and that will allow this React app to talk to the blockchain. So once we have Web3 set, I'm going to grab an abstraction of our contract. Now, this is one of the important parts. So a lot of people are just using Web3 by itself to talk to their contract in their client-side applications, but I don't like it quite as much as I like using this Truffle contract for a few reasons. First of all, a lot of people will just paste their contract ABI into their files. Now, if you don't know what ABI is, it's an abstract binary interface. This is basically what allows you to kind of generate a contract for the EVM, Ethereum Virtual Machine, and for your client-side applications like with Web3 or Truffle or something like that, or Truffle contract. This is what an ABI looks like. And you need this in order to, basically generate a contract. So a lot of people just paste this into a file. And also, you need to know about your contract address, and your contract address can change based on, environment. And also your ABI can change if you're developing your smart contract and your functions change. So that leaves you to copying and pasting a lot of values into your application all the time. I mean, yeah, you could configure maybe like an env file or some other JSON file. But we're going to get this, JSON file that Truffle is going to build for us for free when we develop with Truffle. It's going to give us this ABI that's going to change anytime we run our migrations. And it's also going to give us, different addresses of our contract based on the networks that we configure. So if I deploy this to a test network or the main network or a development network, these addresses are going to change, right? And this whole JSON file that's supplied by Truffle for free is going to know about all those changes. So in my app.js file, I'm reading that election JSON file and generating a Truffle contract that we can use to interact with. And that saves me from having to copy and paste a bunch of stuff or configure, some other scripts that are going to, they're going to get read. This just gets a lot of stuff out of the box for free that I really like. And that's exactly what I'm doing here. I'm creating a Truffle contract from that JSON file, the very intelligent JSON file and very intelligent library of Truffle right here, Truffle contract. So then I'm going to set the provider. And also, yeah, I don't think you really appreciate this until you've had to use Web3 and like keep setting the address based on environment and keep changing the ABI while you're developing. It's kind of annoying, and this really solves that problem. So anyways, yeah, I'm setting the provider, and I'm just binding some of these events here. Sorry, I'm binding some of these functions to the scope of this app component because I'm passing them down into other components. And that's kind of just a React thing to do. Now let's talk about the app state a little bit. Like I said, I'm using component state here to manage, some basic things just like the account that's connected, the candidates that are going to be in the election, and some other stuff like has the account voted, is the app loading, is the app currently voting. So let's take a basic example of how I'm using state. Like essentially, if the app is loading, if I'm still like trying to load up a bunch of data from the blockchain, like we're going to hide some of this content and show a loader, right? That's kind of what I'm doing here. So this is React's big render function for this component. React relies upon basically anytime state changes in React, it's going to re-render, right? And so whenever it does that, if it's loading or if it's voting, then I'm just going to show this loader. And if it's not, then I'm going to, render the content here. So that's an example of how I'm kind of using simple state values, but I'm also using state to manage the data that we get back from the blockchain. So like I'm using state to keep track of these candidates here and like has this user or this account voted in the election yet. So I'll kind of show you how I'm doing that. So I'm doing that with the React kind of lifecycle function. Did this component mount? And if it did do this stuff, that's essentially what this component did mount function does. And you can see I've got a little to-do note here that I want to refactor this, and I probably will. Kind of getting into, what a lot of JavaScript developers affectionately call callback hell here. I'd like to kind of refactor this with a promise chain, which I haven't quite done yet. So if you get this code from the master branch, this might be updated by now if I've changed this. But like I said, just check out the release link in the description below to get this code at the current version. And I'm also, welcome to collaboration. So if you all want to, make a pull request on improving any of this, feel free. I'd be happy to check those out and see what you all come up with. But essentially what I'm doing here is just getting all the values from, the blockchain and hydrating the state of our app. So I'm getting the account and setting that to state. I am getting the instance of our app, of our contract, and I'm just writing that to the component. And then once that happens, like, we're just listening for the events, like waiting for a user to vote. And what I'm doing here is actually loading up the candidates from the smart contract, from the Solidity mapping, and adding those to an array of candidates in the state. And also, I am reading from our smart contract from the voters mapping. I'm saying, has this user voted, or has this account voted? And I'm writing that value to state. So down in our form, we're saying I've passed in state via props. So in React, props are just a way to pass data down into your child components. Basically, I'm reading that value, has voted. If they have, or if they haven't, show the form. And if they if they have, then don't show anything. Yeah. So the big kind of challenge with developing, the client side of these decentralized applications are, finding a way to effectively, wire up your front end application with the blockchain. And that's what we use Web3 for. And then we use Truffle contract to read our contract abstractions. And then basically with React, like I said, I've been trying to hydrate the state with, this kind of logic here. And this, like I said, this is going to be refactored and broken up into some cleaner, more kind of bite-sized chunks. But because of the asynchronous nature of smart contracts and smart contract development, you do have to wait for certain things to be finished in order to execute other commands. Like, we can't watch for events. We can't watch for a voted event until we get an instance of our smart contract. We can't try to read a candidate out of the candidates mapping until we have a candidate count, for example. We don't know how many candidates there are. You can't really do that in Solidity. There's no way to know the size of a mapping. That's why we have to loop through this. So yeah, other kind of other functions in this app component are, watch events, kind of self-explanatory. I'm watching for the voted event. Whenever that's, triggered, basically we'll say that they're not voting. And our cast vote function, which talks to our smart contract. Again, we have a copy of the election instance written to the component here, and we call the vote function, and we pass in the account from state, pass in the candidate ID. And you'll notice that you don't see a call to cast vote inside this component. That's because I'm passing our values down with props to our child components. And these will get broken out into each component that actually needs them. So you can pass in things like just regular data, like what account is using the blockchain. We can pass that in down into the content. The candidates that we've stored in state, we can pass that down to the content component. It has the account voted. We can pass that down, but you can also pass down stuff like functions. So we can pass down the cast vote function. Now, if you want to preserve the resolution of this inside something like cast vote, you must first bind it to the parent component. That's what I've done here. So like this.castVote equals this.castVote bind this. And that's pretty important, or else it won't know how to set state with this.setState. So you go down to content. You can see this just renders the table. And we pass in the candidates with props. And we just map through those candidates and render them out. And we do, also we, render the form here if the account has not voted. And if they have, then we don't show anything. So we just pass in the candidates that we need in order to select. You know, we need to know about which candidates there are. And we also pass in the cast vote function with props. And we do that like this. So we build a form down here. We have an onSubmit handler that calls cast vote, and we pass in the candidate ID value. And with React, you know, we manage this value with ref, and we do that this way. We put a ref on our select here, and this calls a anonymous function that assigns the candidate ID to the component from this select value. And we build this select out by just mapping over the candidates from the candidates passed in by props, and we render a select option with the candidate ID and the candidate name. And then I think the last thing is just showing the account that's listed, on the bottom of the content section with the value that was also passed in by props. All right, so that's our tour of our election decentralized application, rebuilt and modernized with React.js and Webpack and Web3 and Truffle contract. Hope you all enjoyed that. Like I said, feel free to contribute to that repository if you'd like to on GitHub. You can issue pull requests. And if you want to see the code at the current version, check out the releases that I have listed in the description below. Otherwise, just clone the master branch, which may have changed a little bit since I've recorded this tutorial. But yeah, check that out. I hope you all liked that. Be sure to subscribe to the channel if you'd like to see more videos about how you can build decentralized applications on the Ethereum blockchain. And until then, thanks for watching Dapp University.